off the levers. These are brake bars. So they wanted straps, and a few of the people said, hey, why don't you add straps to the chair? Another issue was our parking brake, and you can see it on the red chair, is mounted up high. And if you were really cranking away on the levers, you could whack the lever into the brake, and it would be really disruptive. So we knew we should change the position of that. So that led us to the last prototype that we tested in India, and we rectified those issues we heard about in Guatemala. We added, I'll shoot the seat backs off this, but this has a chest strap, a waist strap, and the foot strap is on there. So we added those straps as options. We lowered the parking brake by 4 inches, so it was out of the lever swing range, but it was still high enough that if you accidentally dropped the levers, they wouldn't hit into the ground and like dig in and catapult you out of the chair. They catch, you'll see it here, they catch the levers before they can hit, right? That was intentional. So we rectified that, we went back. These were all average Joe people who tested this. These are guys like right out of the hospital or living in rural areas. So we felt pretty confident, and we got more data, but we felt pretty confident that these were, really legit results. So 50% faster, 28% more efficient. And then we did the same follow-up survey questions, and it was at this point that we saw, we were about at par with regular wheelchairs indoors and just were really superior off-road. So it was at this point that we felt like, we're pretty close to a commercial product. One of the comments was the storage area in the back, and actually who has the big wheel? If you look at the top of that has another redesign that we had to implement. It's just a really subtle thing, but you'll see at the top it has this little collar, and this block of metal below it is the connection that you have on a bicycle to connect the crank arm, which is what your pedal connects to the chain ring. So we cut the crank arm off, we use that coupling because then we can connect it right into a bottom bracket, which is what this is. This is a pedal bearing of a bicycle, and this is the same connection you would connect your crank arms for your pedals to. So that's all great, off-the-shelf stuff, all bike parts. But the problem is the length of engagement was relatively short relative to like the wiggle room in here. So over time, this thing would wiggle up and start falling apart. So we increased the engagement length to about 2 times the diameter, which is really where you want to be anyway, by just adding this little collar. So we got that. That was a good follow-up design change that happened. Okay, so we did India. We were confident we could go into production. We teamed up with Jaipur Foot, which is the biggest disability group in the world. They connected us with Pinnacle, which could make the chairs, and I talked about that last time. And we also started Grit, which is our startup company. It's an independent company outside of MIT, and it's now selling the LFC. And we were able to hit that $200 price point. I shouldn't say it on camera what it costs, but we make a profit off this. And we chose to do a for-profit company rather than a non-profit because we want to be sustainable and we want to keep the quality high. So at the end of the semester, the CEO of Grit is going to come talk to you about the whole business side of actually turning this prototype from academia into a product, right? And that was something that last year's students requested that they hear is like, you take this class, you may come up with great ideas, what do you do next, right? And so we can talk to you a bit about what we did next, and you're going to be able to contrast that with Bob Hawk from GE, where he'll talk about the big multinational approach too. So that'll be cool at the end of the semester. So anyway, I showed you this picture last time and how we had to bring all these stakeholders together to make this project work and where Grit fit in. And I wanted to just throw this slide up. I posted this paper under your reading section. You don't have to read it, but it's a great resource if you want to read it. It's called Customer Value Chain Analysis. And this ties into that idea that I was showing in this slide, where we had a bunch of different stakeholders that we had to figure out their needs in order to get a product to market. And this is showing the same type of process where you have this NGO trying to develop a product, and donors and governments and citizens are all putting inputs, of what they need. You may have a corrupt government official that you got to send money to, and you don't really know maybe what they want. And like just mapping out this whole array of stakeholders that you're going to have to consider in your design is really valuable. So this is a good resource for you guys. Okay, now back to the point that somebody made about price points in different markets and stuff, and IP generation, and if it's different. This idea that I'm going to talk about, constraint-driven innovation, is really, really core to my group, and I think what we're going to find a lot in developing and emerging markets, and why we as engineers have to, make high-value, low-cost solutions for these markets. So where we were at the beginning of this project was we could look at the various wheelchairs available throughout the world, and you have your high-end off-road all-terrain wheelchairs that cost $4,500 plus, and then you have your developing world kind of cheapy low-quality wheelchairs that are maybe $150, but they don't hold up really well. And the issue that we had was that we knew the market wanted performance similar to these chairs, but we had to hit a price point down near the developing world wheelchairs to be successful. And I think as you guys look at development challenges and realize that people in these markets want just as good or near quality as what we have, but for a lot lower price, you have to innovate. And because we realized this discrepancy of where we had to be versus where existing technology could get us, we had to go disruptive, right? We had to intentionally design a disruptive innovation. But what's exciting about that is once we did design it, we could say, wait a second, we can modify this product platform, bring it up to wealthy markets. We know the price points of wealthy market wheelchairs, and we can maybe undercut them a little bit and sell in wealthy markets, right? So this started this whole idea of like, why don't we make this a global product? And that was in large part driven by, oh man, class is over. That was in large part driven by people in wealthy markets saying, hey, we want one of these too. So I guess we're gonna have to do a to be continued, because I haven't even talked about this chair. But we'll continue that at a later time. Or can you guys go 4 more minutes? It is 2:27. 3 more minutes. 3 more minutes. All right. I'll give you the really quick rundown. Yeah.
I need to, before people start running, we have to go early. Does Sunday work for everyone for the nano testing? We're gonna have all day Sunday testing. This Sunday coming up. No. Okay. I might do 1 or 2 sessions on Sunday, and then I'll try to schedule more next week. Also, Friday, I'll start doing laser cutter and 3D printer sessions. I might try to schedule one on Thursday too. I'll send out sign-up sheets this afternoon. So.
Okay. Let's stop here. I'll fill you in later. But how would evenings work for people for the nano testing on weekdays? Is that better than weekends? Yeah. I think we should do a few evening sessions. Cool. All right. See ya.